Is recording. It's recording. It started. Okay. Hello everyone, welcome to the IA2 Science Masterclass. I am Freakiest DarciLiam. This is co-hosted by Polaris. He's not here right now, he'll be here in a few minutes. But for now, I'll be your host. Yeah, Elephento, I will send the recording. It will be uploaded on YouTube by OliBD. Yeah, what Sam said. So, this is how tonight is gonna go. So, as always, times are approximate because we don't know how long, like concretely, how long these sections will take. But starting off, we will have a we will go through this PowerPoint where I'll explain all the possible experiments, the suggested structure, and an explanation of what each section in the structure has to actually do. And I will give a quick mini exemplar on how to calculate maximum and minimum gradients. And the second part, in that starts around 7:45 to 8, will be an exemplar presented by Polaris. He will run through an exemplar student experiment, and at the end we will have a joint Q&A session. And this will go on however long you want, but please don't make it another 4-hour masterclass like last year's Chem 1. Okay, so first off, let's cover some IA2 basics. So, as the name suggests, this is a student experiment. So, you as a student will do an experiment either by yourself or with a team of people. This should examine a specific variable or concept that is related to Unit 3 content. So in physics, for example, in physics, you're most likely going to take an equation that is related to Unit 3, and you're going to change something about the equation to measure one specific variable of that equation. You will record data with multiple trials, and you'll need to process this data for your calculations, including averages, your graphs, your uncertainties, all that stuff. You'll present your results and findings in a lab report style, and your paper should address your research question, which is essentially the whole point of the student experiment, and by the end of it you should have a definite answer, or at least an answer with a lot of evidence to back it up. The important thing to note is that this is marked by your school. We at QSH can't give like objective advice on what will be marked highly by your school, because it's going to be marked by your teachers, not by QCAA. So if you're unsure about anything, or just in general, just ask your teachers and double check with them if you should be doing this or that. TLDR, you're just pretending, you're role-playing as a scientist. So, likely experiments. So for physics, like I said, you will be looking at certain equations, formulas from Unit 3 content. So these are formulas you can often find in your formula book. So with a force on a current carrying wire, which is what Polaris recommends, you should be modifying the F equals BIL sine theta equation. With projectile motion, you have the range equation, which I can't remember off the top of my head, but it's like v squared sine 2 theta over g or something. Inclined plane, you'll be doing mg sine theta. Circular motion, you'll do v squared over r. And what you're essentially doing is you're taking those equations and changing one variable, isolating one variable that would be the variable you're measuring, and then changing the other conditions. So, for example, with the force on a current carrying wire, F equals BIL sine theta is the equation, and you might change I, which is current. So you'll hook the current carrying wire to a ammeter, you'll change the current, and whatever you're measuring, For example, maybe you're measuring the force that the current carrying wire emits. So when you change I, you'll measure force, then you'll plot that relationship and write a report on it. Chemistry is essentially the same thing, however, it's a bit more vague on what you can and or should experiment on, since there's not as concrete equations like in physics. You pretty much have three options with chemistry, and those are electrolytic cells, galvanic cells, and titration, which are basically the three big areas of Unit 3 content. So you have redox and acid-base reactions and balancing equations, like that. So with electrolytic, you might have cooked data and you might find it hard to have a consistent coating on the electrodes. I know I personally did electrolytic for chemistry and I had absolutely cooked data. It was nowhere near what it was supposed to be, but as I'll explain later on, it doesn't matter if your data is cooked or not. If you have good cooked data, then that's actually might be better for you because you can yap about what went wrong or what went right. With galvanic cells, this one is Polaris recommended. It depends on your teacher and your aim of the student experiment with what you're measuring and what your graphs will look like. So Polaris himself said that he did galvanic cells, and I believe he did something related to the Nernst equation, which used a logarithmic function. So he had to linearize that based on what his teacher said. But again, the IA2 is marked by your own individual teacher, so you need to consult with them to understand what they want from the IA2 and what they will consider a 20. The next experiment for chemistry is titration. This one might be the easiest to conduct because if you've done chemistry in year 11, you would have gone on the titration incursion, I believe. So you would have some experience with titration, and it does seem like the simplest experiment. You're essentially just dripping liquids into another container. But this might be lacking in theory because essentially what you're doing is balancing equations, so there might not be much to talk about. Now onto biology. I didn't do biology, Polaris didn't do biology, but Johannesburg did do biology. I asked him, and he just said, I don't know. So, if you want to, get a more detailed answer on biology, I would recommend asking him. But what he said is that biology experiments are essentially biodiversity related, and it is almost always paired with a school excursion, and you basically have free reign depending on that school excursion. Now, there are a lot of experiments to choose from, but the important thing to note is that whatever experiment you pick, you can get a 20 with it. It just depends how good your actual write-up is. So if you are struggling with deciding what to choose an experiment that you are confident you can write a lot and in detail and in a very high level about. So if you think that titration might be the best experiment for you to get good data with, but you don't know what to write about, I wouldn't recommend doing that. Instead, galvanic cells might be better since you can write about things that went wrong in the experiment, and that will add up in your word count to give you that 2,000 words and that level of detail that a 20 is needing. Now, the structure of an IA2, and this can vary because, again, it is marked by your teacher. It is not marked by QCAA. There's no set, there is no objective structure with what you should do these in. So first off, you have to have your rationale. That's kind of self-explanatory. Your research question, your method modification, your risk assessment, diagram of figures or an experiment setup, essentially just some information on how your experiment was conducted. Then you'll have your raw data, your sample calculations, which are just an example of each calculation, each major calculation that you do that's related to your data. Your process data, so this is if what you're doing when you go into Excel. So you'll have your averages, your graphs, your uncertainties, all of that stuff in there. Then this is the meaty bit. So your analysis or your discussion or your interpretation of results, essentially where you're just saying what the experiment showed, and like all the trends, all the relationships, all the patterns, all that like stuff that really gets into the nitty gritty of what your experiment's data means. Then your limitations and extensions and your conclusion. So the rationale. This is almost the most important part in your student experiment. I've had teachers that have said that when they're marking student experiments, they just read the rationale and skim through the rest. So if you need to perfect something in your IA2, this is the part to perfect. So your rationale is essentially an introductory paragraph introductory set of paragraphs that introduces the theory behind the experiment, and you start from the general theory and you narrow to the theory and the details about your specific experiment. So essentially you're just starting with the Unit 3 content that you learnt in class, or the vague stuff about that. Then you narrow it to a specific part of the Unit 3 content. For example, voltage production in galvanic cells, or like force on a current carrying wire. Then you introduce the original experiment that you're basing your student experiment on, and you'll introduce all or most of your theory, equations, variables, constants, and all of the important data and like variables that you're going to be using and changing in the experiment. Your rationale should essentially be the setup and introduction to the experiment. So from an educated reader's perspective, so like just a random scientist, they should be able to read your rationale and know exactly what you're doing and why. Yeah, so they should be able to logically follow it and then understand what your experiment is and what it's measuring by the end. Now, your research question. This is just as, or possibly even more important than your rationale. So this must be specific, meaning that it should include all of the important information about your experiment. So your units, what you're changing, the variable you're changing, how much you're changing it by, what type of equipment you're using, all of that stuff. So like so an example research question would be something like, how does force in newtons on a current carrying wire, which changes ampage by 0.2 increments, blah blah blah, using this model of ammeter, this type of wire, extremely specific in your research question. And your research question must be a question that can be answered with your data. So it needs to be some sort of quantitative or very objectively qualitative question that you can answer. So if the trend is linear, if a value that a specific constant can be verified, if you're trying to find a relationship, all of those can be answered with your data. If you're doing a qualitative research question, such as in biology, I believe, I'm not too sure, but I believe you might have qualitative research questions and experiments in biology. If that's the case, you need to make it very as objective as possible and as specific as possible. So if you're like incubating bacteria in a petri dish, you need to be able to answer that question with the data of your petri dish. So like if you're taking pictures of the petri dish, you need to be able to confidently point to those pictures and say, yes, that shows that the bacteria has grown from circles to spots or something like that. I didn't do bio, don't attack me. Oh, hey, Polaris is here. So and with the method modification, this is essentially you're introducing, or not introducing, you're explaining the original experiment that you took and you modified to become your own. And I'm not sure if I mentioned this before, but in this student experiment, you need to have a source for your experiment. So like a source of where you got the idea or the method or the techniques from. So this doesn't have to be like specific, just Google something on the internet and source it, or like look in your textbook. And with your modifications, which is the important part in this section, you need to explain there are three types of modifications. So there's redirections, which is changes to the experimental purpose. So if the original experiment was finding a trend or finding a qualitative change, you will be changing that purpose and redirecting it towards something else about the specific theory or experiment you're doing. So, for example, if your original experiment was like an inclined plane, and you were sliding blocks down a plane to verify the acceleration of gravity, maybe you can do you can change it to verify whether the linearized trend based on changing angles is actually linear or not. So essentially just changing the question that the original experiment's research question was asking, in a sense. The second modification is an extension, which is changes to experimental design. So for example, if you were testing 3 concentrations of acid in the original experiment, an extension of that experiment would be to test 7 concentrations, because that will give you a better picture of the trend of behavior that the acid has. And the next modification is the refinement, and this is just an increase in validity or reliability, or just like a small minor change. So for example, increasing trial number, increasing the time measured, or measuring time with a stopwatch instead of human counting. So just like small changes that just increase the validity or reliability of the experiment by just a little bit. Now, what is validity and reliability? So these are different from accuracy/precision, which refer to the quality of your results. But in the method modification, they're different. So when we are talking about them in the method modification, we mean that validity, we mean it refers to how well an experiment can establish a trend or a change. So if you're measuring the change in concentration of acid, and you're measuring how that affects reaction rate, for example, which number of concentrations tested would give you the strongest trend/pattern? It would be 15 different concentrations instead of 5 different concentrations, right? Because that gives you a bigger picture, and you see the trend and how it establishes itself on a grander scale. So validity is referring to the trend and how well your experiment can truly represent the trend that you are measuring or testing on in your data. Now, reliability is how much you can trust each data set, or essentially trust each point in your data. So examples of increasing reliability is increasing trial number, as if you do more trials, you're likely to see the average, the true average of each trial, instead of just doing a few trials and getting misled by outliers. Another example is reducing human error and using more precise instruments that give more consistent results. Now, the next section is the risk assessment, and you can either write this in a table or in a list. So so the parts of your table or list should be the risk, the management of risk, and environmental/ethical concerns, which only really apply to chemistry and biology, but physics might have some of these anyway. And again, some teachers might want you to have environmental/ethical concerns in your risk assessment no matter what, so check with your teacher. Now, each individual aspect of the risk assessment is sort of straightforward. The risk is essentially what's dangerous about it. Like, if you're dealing with chemicals, if you're dealing with electricity, if you're dealing with, I don't know, bacteria, those are potential risks. Now, management of risk is how you prevented, avoided it, how you planned to deal with the chemicals or bacteria in a way that didn't risk your health, and you need to source these. So you can just Google any PPE guide and just like don't copy paste, but like paraphrase it from that PPE guide. Like, just Google some like chemical data sheet online and you can easily get your source from there. Environmental ethical concerns, I've already gone over that, but yeah, essentially it's like if you're dealing with chemicals and you're needing a way to dispose of them, an environmental/ethical concern is whether flushing the chemicals down the drain would be dangerous to the aquatic wildlife. And you also need a source for these. Again, check with your teacher, because they might not need one or they might not expect you to have one, but it is good practice to have a source. And another thing about risk assessment is that some schools might have this website called Risk Assess, which is just like you enter your experiment and the type of chemicals or biological agents that you're dealing with, and it will generate a risk assessment sheet for you. And you can essentially just source that for the entire risk assessment. Now, your raw data, this is essentially all the stuff that you measured from your experiment. Like, if you wrote your experiment values in a notebook, take all those values from the notebook, and that's your raw data. This is what you recorded during your experiment. And when you're representing these in your student experiment, you don't need averages, but if you're wanting a bit of completeness, you can have the averages in the raw data, since it's a very minor calculation. So that seems pretty straightforward. By the way, if you have any questions, just ping me in on Discord and I'll read the chat. Now, these sample calculations, these are pretty basic. Like, well, not basic, but like you don't need to put in a lot of effort for these, and they're not judged to a higher standard. So they're just step-by-step example calculations of your major calculations. So your averages, your uncertainty of averages, your absolute and percentage uncertainties, any relevant theory equations, like if you're deriving the value of gravity, or you're linearizing something, or you're like, especially for physics, like if you're doing F equals BIL sine theta and you're rearranging to find B, include that in here. Percentage error is optional. I believe, check with your teacher though. Again, disclaimer, this can be calculated in the discussion section, which is what I did for my physics student experiment, but it does make sense to put it in the sample calculations. So again, check with your teacher. And you should use a consistent data set for all of these sample calculations. So like if you had different ampages, so you had 0.1 amps, 0.2 amps, 0.3, in your sample calculations, use the data set for 0.1 amps all the way throughout. So I had these sample calculations in my physics student experiment, and as you can see, let me just get the laser pointer. As you can see, there is the formula. Oh yeah, you should have a formula on the left column. So there's a formula for the actual how to actually calculate it. And as you can see, I have the average, uncertainty of average, percentage uncertainty, absolute uncertainty, and I derived the equation to get acceleration. And I have these sample calculations for the 10-degree data set, and these are consistently, they're all values from the 10-degree data set. So that's pretty straightforward, I believe. Is there any questions? Alright, let's move on. Okay, so process data. So this is where this is where your raw data turns from being just numbers into something you can analyze. So this contains some tables with uncertainties, your graphs, your trend lines. These last two are really important. In your process data, you'll plot graphs, and they will have trend lines that match a theoretical trend and both horizontal and vertical error bars. You need to have both. So your trend line should be what it theoretically should be. So if your equation should theoretically be linear, choose a linear trend line. Like even if your data shows a polynomial, like it's going like straight up, still choose a linear trend line. Some subjects need a maximum and minimum gradient. It is good practice to do it for all your subjects, but from my personal experience, I've had chem teachers that like say that this chem student experiment doesn't need a maximum and minimum because that's a physics thing. Personally, I think that's a load of like bullcrap. It's good practice to have max and min in all your student experiment data, but still check with your teacher and check with like all the other science teachers in your faculty, because your teacher might be the one that has like a controversial opinion. You can include past experimental data from the internet to compare. So if your data is beyond cooked and there's no legible like anything that you can get from it, you can include a past experiment that has like a decent graph to show what it actually should look like, and then you'll discuss that in the discussion section. Or you could include the past experimental data in the discussion section itself. It's up to you. Now, graphing 101. So, graphing, you'll be using Excel or Google Slides. Essentially just a spreadsheet software that has the capability to do calculations and plot points like this. In your graph, you must include a trend line, error bars, a legend, axis titles with units, and equation trend lines with your main trend line having an r-squared value. And with the r-squared value, you don't need to know what that is, you just need to know what it means. And you can have a caption on the table, on the graph, or you could have it under the graph in the Word document, but you need to have a caption for the graph. You just need to have one. It doesn't matter where it is, as long as it's somewhere. And max-min gradients, however, some teachers might not feel like their subject needs one. And the title, the title is optional and it can be in the caption, as long as your caption has like a description of what it is. Now, max-min gradients. These are something that I've noticed a lot of students struggle to wrap their head around and to actually pull off in Excel. So I'll do a mini exemplar shortly to show you exactly how to do max-min. Firstly, confirm with your teacher if your max-min is required. Polaris said that his teacher allowed only a linear trend line. For your max gradient, what it should do is go from the lowest rightmost first point. So for your first data set, you'll have horizontal and vertical error bars. The max gradient's first point should be the lowest and rightmost possible of that data set, and it should connect to the highest leftmost last point. And this should be the steepest possible gradient when considering the uncertainties in error bars. So like if the uncertainties in the error bars, if your actual data set point could be anywhere in that area, the max gradient should be the combination of the first data set and last data set being in the right area, being in the right place in the area, so that its uncertainty, so that its gradient is the highest. Same thinking with the minimum gradient. It's your data sets being in the point where your gradient is the lowest. So for the first point, it should be the highest leftmost part of the data set, and it should connect to the lowest rightmost last point of the data set. And this should be the least steep possible gradient, so the lowest gradient. How do we do this in Excel? Okay, so what you want to do is make a separate table separate from your main data, and you need to have 4 columns and 2 rows. So as you can see, we'll have 4 columns, and this is the X and Y coordinates for your minimum and maximum gradients. So each of these, we have 4 columns because we have 2 coordinates each for minimum and maximum, and 2 rows because we need to have a first point and a last point for minimum and maximum gradients. And what you do is, with your Excel calculations, what you do is you input your first and last coordinates and then add or subtract their respective uncertainties. So it depends which point and which maximum or minimum it is, but it will all make sense when you sort of see see it in action. So for the minimum, for your first point, subtract horizontal for your X coordinate, and then add vertical for your Y coordinate. For your last point, subtract vertical and add horizontal. For maximum, just switch the subtraction and addition around. So what it should look like is that the minimum has your coordinate subtracted by the horizontal uncertainty. So subtract horizontal from first point, and you add the vertical uncertainty to the first point as well. For the last point, you add it and then subtract it from you add the horizontal and subtract the vertical. So, is all of this making sense? Hey chat. Is all of this making sense? Okay, yep. Does anyone need me to go through an exemplar of calculating it in Excel live? Okay, A said yes please. Okay, Casey wants an example please. Okay, Kevin, okay. Okay, I will stream Excel. Okay, can you see this? Okay, so I have so this is the table from the PowerPoint. I have pretend data here, it's fake. So you will first of all you'll make your own graph, like just a standard normal graph with a normal trend line. And this is an example of I'll just quickly go through an example of how to do this in Excel. So you want your independent variable, I believe. No, dependent variable, which is the one you're changing. You want that to be on the left, and so I'm changing current by increments of 0.2. I will highlight this and control click and highlight the independent variable, which is the one I'm measuring. So I'm measuring the force. You'll go to insert, you'll go to charts, and you'll go to this little dot point section here called scatter chart, and you'll click the one with the normal dots, no line connection or anything. So that's insert, charts, scatter, the normal dots. Now this is just points on a graph, so there's no trend line whatsoever, and there's not much of anything else, but I'll ignore that. So like obviously you'll have like a legend, you'll have axes titles, you have like a descriptive title up here, you'll have all of that, but for now I'm going to be focusing on the trend line itself. So to get a trend line, you go to chart elements, you go down to trend line, and you can select your type of trend line. So if you go chart elements, trend line, hover over the arrow, click on the arrow, sorry, and you'll have a list of options, and you can go to more options. So say that this was a sort of sinusoidal relationship. I would go polynomial for that, or logarithm. No, polynomial. There's no sinusoidal relationship in Excel, but polynomial would work. Polynomial would give a good approximation. But as you can see, my data really isn't polynomial. Ignore the fact that it's fake. But so if it was a sinusoidal relationship, you go polynomial. If it was logarithmic, you go logarithmic. With my data, it's current and it has a relationship with force. This is a F equals BIL sine theta experiment. So since it's F equals BIL sine theta, current is I, that means that F is directly proportional to I. So it is a linear relationship, and we'll go and change that right now. So chart elements, trend line, click on the arrow and you go to more options, click on linear, and it will be a linear trend line. Now you can set an intercept or not. Check with your teacher if they want one. My physics teacher personally did not want to set intercept. However, I might be misremembering, and it's always good to check with your teacher. So set an intercept if you want or don't. And also, you have to display your equation on the chart and display R squared value on the chart. So these are these two little boxes down here. And you can move this around. You can change the color of the text, and you can just position it so that it's easier to read. Now, for the min and max gradients. So here I have a table, a separate table. I will have 4 columns and I'll have 2 rows. For the minimum, the first x coordinate, this will be, so an easy way to do this in Excel is you hit equals, you click on the cell of your first x coordinate, and for me it's current with 0.2, you click on that, and then you follow the way to calculate it, which is you you need to add error bars before you add max and min gradients. So the way to do that is you click on error bars, click on the arrow and go to more options, and then you click on if it takes you to this page where it changes the appearance, just click on the graph button, and with the error amount you go custom and you specify a value. So before you click custom, you need to click on which error bar you want to select. So I've currently got the horizontal error bars highlighted. With the horizontal bars highlighted, I'll be changing the horizontal uncertainty. So with custom, click specify value, and you'll have positive and negative error. I don't think anyone will be doing any experiment which requires them to have different error values depending on which side of the data set it is. So your positive and negative should be the same. So to choose this value, first highlight your value in the box, then go to your table and go to your uncertainty column for your horizontal uncertainty. So as you can see, I have the current uncertainty here. Then you highlight all of this, and then you do the same for the negative error value, highlight all of it and click OK. So that has changed the value. It might look like it's disappeared, but it's just gone very small. If you zoom in really close, you might see some parts of it poking out. And same goes for your vertical error bars. You go custom, specify value, you highlight your positive error, and you go to your uncertainty for your vertical. So I have my force uncertainty, which is my vertical axis, and I highlight all of that. Same thing with negative, highlight the box, highlight your column. Highlight all of your column. If it has, if you look here, if it has the equals bracket 1 bracket plus, just highlight the plus and 1 and just delete that. So that will give you your vertical uncertainties. So now you have your trend line, you have your error bars. Now you just need your max min gradient. With your max min gradient, for your minimum, first x value, click equals, click your first x values box in Excel. Then press minus, press the subtract button, and go to your uncertainty for your horizontal uncertainty, and then click enter. For your y, go equals, click your first y value, your first independent variable value. You click the box, and then you press plus. Then you click on your vertical uncertainty. Right, so you have your first x value minus uncertainty of your first x value, y value minus plus uncertainty of y. For your last point in your minimum gradient, press equals, click on the last x point. So click on the last point in your graph, and then you press plus for your last x point for your minimum. Now you will click your uncertainty for your corresponding uncertainty for your last x point, your corresponding horizontal uncertainty. Then you click enter. Now for the y, it's the same process. Click on your box of your corresponding point, then you subtract this one. Now click on your corresponding vertical uncertainty and click enter. Now with the maximum, it's the same process, just switch your plus and minuses. So maximum first x equals, click your box, click plus the uncertainty. First y, click your box, click your box, and then minus the first uncertainty. Yeah. And then your last x, click your horizontal point, then you minus the horizontal uncertainty. For your last y, for your maximum, click equals, click your box, and then you add your vertical uncertainty. Right, now you have your points. What you want to do is go to your charts, press chart design, and press select data in your data column in chart design. Chart design, data, select data. In the left box, there will be add, edit, remove. You want to add, and you can name the series whatever you want. Let's name it minimum gradient. For your x values, click and highlight the column that you have received, that you have made. So same with your y, click your corresponding columns, and that's your series added for minimum. Now we'll add another series. Let's call it maximum gradient, because this is for the maximum gradient. Click and highlight the corresponding x and y that you've made before. Yeah, as you can see, sometimes it glitches and you get the 1 plus the sheet range. So just delete that. And so now we've got those series added. And as you can see, there are points added onto the graph. What we want to do is we want to go to chart elements, and we're going to want to go to trend line again, but we want to click on the arrow and go more options, and there's add a trend line, and it's based on the series. So we want to add a trend line for minimum gradient. Now we go to trend line, format trend line options, and we'll click linear, because the gradients are always going to be linear since it's a direct line between 2 points. So linear, and we want to just display the equation. We don't want to display the r squared value because it's always going to be 100. Since it's essentially always going to be accurate, since it's a linear line joining 2 points on the graph, it will always be accurate. So r squared will always be 1 for that. Next, we want to do 1 for the maximum. We go to trend line in chart elements, trend line, more options, and that has auto-filled our max gradient. Now display equation, and you now have your minimum and maximum gradients. A good rule of thumb to check whether you've done these right is to see if the maximum and minimum sort of form a diagonal with each other. So in here, my minimum gradient goes from the top of the normal trend and crosses over to the bottom. My maximum goes from the bottom, crosses over to the top. These form a sort of very thin cross. If you have the very thin cross, you've done it right. If you have like parallel lines running beside each other without much deviation, then you've messed up the order of your subtractions with your max and mins in your columns. So that's how you do maximum and minimum gradients. And another thing to note about these gradients is that the values in the equation are going to be the values you'll use to calculate your uncertainty of the gradient. And that's just taking the difference of these and dividing it by 2. So it's like how you find the uncertainty of the average, except you're essentially just averaging these 2 points. Yeah. So that is how you calculate how you make maximum and minimum gradients on Excel. Is that clear for everyone? A lot of GIFs going on in the chat. Yes? Yep. Okay, cool. Let's switch back to PowerPoint. And let's continue on with the PowerPoint. Alright. What if your data looks like this? What if it's absolutely cooked? That's fine. That's no worries at all. Like I said before, if your data's
Wait.
yeah, go ahead.
Hello, everyone. If you go back to the other slide, can you just like move the things out of the way?
Wait. Yeah.
Like move the images. Does it? Oh, it doesn't work. Oh, because you in wrote slide mode. I forgot. Never
Wait.
mind. It's right.
Is it showing on Discord?
You're like,
Okay. Okay, is it showing now?
oh yeah.
Okay. Okay, Polaris has added a very important comment. You can
And
fake
I
your
pretty much did
data.
that for all my experiments.
Yeah. You can fake your data. But like even if you don't want to fake your data or like your fake data's cooked for some reason, it like it's still it's still no worries if your data's like these. Uh yeah, like I said before, uh can you see that slide mode? Okay, wait. Can you see that?
Yeah.
Okay, cool. Yeah, like I said before, it's actually a good thing if your data's cooked because you can yap about it so much more than you could with a normal, so to speak, a normal experiment. The worse your data, the more limitations or sources of error you would have had, and you can talk about it in depth in your discussion or later sections like your limitations and extensions. It would be almost impossible to write a good length 20 out of 20 with a perfect experiment. Like, you could do it, but it's so much easier with a cooked experiment. Now, and your analysis section. This is where the most of your writing is going to be in. This can be formatted in any way you like as long as you have the right content. So the analysis mainly focuses on commenting on graphs and data. So you'll comment on trends, trends, patterns, relationships. So trends are the general shape of a graph. So if it's a positive linear, like it's going up from the left to the right, you'll say it has a positive trend. You won't say that it has a relationship of y equals 2x because that's in the relationship and that's the exact mathematical equation. This is good advice for data tests as well. Trends are the general shape, relationships are the exact equation. I'm sure you've already had your data test, but if anyone's in like year 11 here, it's good advice. Your R squared value, so just it's a measure of how strong the correlation is to your trend line. The higher your R squared value is to 1, the better it is. So if you have 0.999 R squared, your data is really good. If you have 0.2, it's absolutely dog water. Comment on any outliers. Like, if I go back all the way here, if you see this thing with the uncertainty going into the negatives, this was real data that I had for my chemistry student experiment. This is a gold mine for content. If you're stuck on anything, yap about this. If you're like super stuck, like fake your data to have this. Like if you have this in your data, you are set for a few 200 to 300 words. Now, you can also comment on percentage error, and also calculate it in the section if you want to, and also comment whether your data is accurate or precise. Now, this is different from valid and reliable in when we're talking about it in the sense of the analysis section. So I'm sure you've seen something like this before, the with the targets and the bunch of dots or arrows around it. So accuracy is how close your data is to the true result, and you need to use percentage error to describe it. So your percentage error is essentially how far off your data is relative to the data. Yeah, ditto. There is a word limit. It's 2,000 words, not including references, not including sample calculations and raw data, I believe, not including the titles of each section as well. But if you but there is often, like when writing student experiments, there is often times where you will get stuck in places, like you'll have like kind of like a writer's block and don't know what to write, especially for the analysis section. Um, so the things I said up before about using commenting on outliers and commenting anything that looks really out of place and just like dissecting it to the ground, that is good advice for if you want to get more like content out of your graphs. So where was I? Precision. Precision is how regular or low variation your data is, or on the other hand, how irregular or like varied it is, as you like saw before with the uncertainty of and the error bars going into the negatives. When we're just talking about these, we'll use uncertainty or percentage uncertainty just to describe it. For example, the relationship's gradient was accurate to the theoretical value. So it's accurate to the theoretical value. So it was 9.7 compared to 9.8. So this had a percentage error of 1.02%. But the graph itself suggests that the trend is weak, as r squared is very low, and the percentage uncertainty of the gradient is very high. This means that the graph is imprecise and the trend is imprecise as well. I forgot to mention, with precision, you can use r squared to talk about it as well, because that's essentially saying how precise your data is towards the trend line. And another part of this section is interpretation / discussion. You're just sort of making informed judgments from the data. So if there's outliers, if there's like huge percentage errors, huge uncertainties, this is where you'll be discussing where they could have come from, what they meant about the experimental design, all of those stuff. So you'll point out outliers, you'll point out patterns, behaviors, all the stuff that you've identified in your analysis section, and you'll discuss the implications that they have on the experiment. So a good things to talk about in this section is that if the results are accurate, if they're precise, why aren't they accurate? Why aren't they precise? Was there sources of error? Like all of that stuff. How could they have affected the experiment? Where could they have come from? Something like thinking along those lines. And this brings us very nicely into our next section, which is the limitations and extensions. This is self-explanatory. It's just a table or list of limitations. This is entirely dependent on your teacher's preference, but you should include in the table or list, you should include limitations, the effect on the experiment, and the improvements. Improvements that you'll make in future to correct those limitations. So with your limitations, be specific. Mention specific points about your data or your experiment setup. Like there was an outlier with the 0.1 amp data set, or the experimental setup meant that the Bunsen burner was far away from the alcohol flask. All that stuff. The effect on experiment, essentially was what type of error, what effect it had on accuracy slash precision in your data, in your process data, or validity slash reliability in your experimental design. So this is where things can get like really confusing when we're talking about accuracy, precision, and validity, reliability in essentially in the same paragraphs. Uh, this is like this is confusing, um, but it is like it isn't impossible, and like you just have to really understand what accuracy, precision, and validity, reliability mean. So accuracy and precision is referring to the process data. So precision starts with the same letters as process data, and your validity and reliability refer to stuff in your experimental design and they how well they establish a trend and how reliably that they can establish a trend. Remember, if something's reliable, you can count on it to be consistent all the time. So validity, reliability is something that refers to how consistently your experiment would show the established trend. In your improvements, you'll essentially just say how you can mitigate this. Some teachers might want sources in this, some won't. Um, Check with your teacher. And the last part of this section is your extensions. These must be justified with like a source or equation or like something from the internet, and you must have two of them for a 20 out of 20. So what does it mean to be justified? When it's something is justified, it has a good like evidence backing it, a good amount of evidence backing it, or a good reason. So your extension for say a physics IA2 might be to instead of changing ampages in F equals BIL sine theta, you could change the angle, or you could add another wire to it, and that is an extension that you can justify with an equation. With stuff like chemistry or biology, when you're like researching theory about your experiment, you'll definitely like come across like more complex versions of the experiment, or like more complex theories to do with your experiment. You can justify extensions by sourcing one of those websites that do talk about complex versions of your experiment or your theory. And you must have two extensions to have a 20 out of 20 limitations and extensions section. So the types of errors: there are systematic errors and random errors, and these generally affect accuracy and precision respectively. And I say generally because there can be times where a systematic error affects precision. I can't think of any on the top of my head, but I have had, through personal experience, I have had times where I have been describing a systematic error, and it was more apt to describe it as affecting precision. So if you do come across those, really dissect the impacts of the error, and don't just assume that systematic always is accuracy and random is always precision. But systematic, systematic is, they are defined as consistent errors such as offset instruments or misassumptions in the experiment. So these are errors that essentially just like shift the experiment away from the theoretical sort of like goal by like one consistent step. So like one constant step, your scale is off by like 2 grams, or you assume that like velocity is constant for an inclined plane experiment. These are errors that if you hadn't had them, or you would have had accurate like theoretical, like correct to the theoretical experiments. or if you do have them, you can adjust them by adding on adding a mitigation factor, and that factor will like bring you back towards the accuracy, because systematic errors are consistent and like they are constant, and you can easily like wrap your head around their effects. Random errors are, like the name suggests, they're random and inconsistent. So these are things like human error, unpredictable behavior, uh, and like just stuff that you literally can't predict. So maybe like the motion of a solution in a beaker, or the path of a ball in the air, whether it's affected by air resistance or hitting a fly or something like that. And these generally affect precision, because since these errors are always going to be different each time, they're gonna spread the hits off of the target, or wherever they were all hitting. It's gonna spread them off in random amounts. So if we go back to the diagram here, a random error would scatter these dots off by random amounts, and that is why they affect precision. While a systematic error would be something that shifts your aim by a constant amount. Alright, and final section is conclusion. This is whether the experiment answered the research question. And you have to have justification for this. You have to have evidence from graphs and results. So you have to say that the actual equation that your graph had, or the R squared value, or the actual percentage uncertainty. And you should always be using language language related to accuracy and reliability. This section includes a brief summary of your main findings and limitations. And that's it for the conclusion in the IA2. So it doesn't have to be very long. It can be very short. You just have to say whether the experiment answered the research question. Just say like the experiment supported or did not support the research question with this evidence from this graph, from this using this had this number of uncertainty, this percentage error, and we found that the biggest limitation was the voltmeter not being fully connected to the beaker. It's as simple as that. And that's all for the PowerPoint. Now we'll run through the exemplar, and Polaris will take over in this section. So I'll sign off over to him.
Okay, hello everyone. Darcy's overview was pretty thorough, extremely good and thorough. So my section will tend to be a bit more quick, just showing the application of the structure. I'll just share my screen quickly. Try to. Let me know if you guys can see. Can you guys see it? You can see the good notes document?
Yeah.
Okay, perfect. All right. So essentially, with my student experiment, my teacher was very weird. He didn't like any tables entirely in the entire thing, and he liked to have the modifications in the rationale. So he wanted modifications to methodology in the rationale in a paragraph. So that just illustrates like teachers. Nah, he was a pretty good teacher at marking. But he was weird in certain stuff, so that's true. So you'll see when I go through. That's why it's important, as Freakiest Darcy mentioned. It's so weird calling him. Okay. As you mentioned, it's really important to listen to your teacher. Are we gonna do a thing to tag the next section? Darcy.
Oh yeah, yeah. I can ping everyone.
Oh yes, yes. But essentially, I've just highlighted this quickly. It's quite rough. Yeah, like exactly what Fish said. If you write it in your rationale, it's easier to be derive, show how you derived it from the research question, and it can make it flow better. So as I'll go through in my rationale, it allows for a better flow. But one of the other things our teacher said is it allows them to kind of like find ways to give you marks. If it's in a table, it kind of has to be like pretty sharp and like straightforward. Whereas if it's like written, the teacher can kind of guess in your rationale from a section that's not really your modifications. Technically, it is, and it kind of just allows more leeway for them to scan you marks. Okay, everyone ready? Shall I start going through or wait for a few more people to come in? Looks like yes, I did get full marks for this. This is 20 or 20 exemplar. Oh, and for reference, not to stress people out, but I'd say 18 out of 24 people in our class got 20 out of 20s for our student experiment. So it is very possible for everyone,
I will say
and
though,
it's
it is also like very easy for the teacher to kind of choose most of the marks, cause QCAA will only confirm a handful of them. Uh, However, like your teacher shouldn't be too generous with the marks, otherwise you might get dragged down. Like your whole class might get dragged down. So that's always a worry, but it is very easy to like get full marks if you like have the put in the effort and like follow your teacher's instructions.
yeah, and in saying that actually, the new syllabus does make that harder though. So for those of you in the new syllabus, you really want to make sure that you're constantly going to the teacher and saying, "Oh, can you is this correct? Is this, you know what I mean?" Just because it's harder for them to be able to scan things for you and it's more risky with the new syllabus. So just make sure that you're paying attention to that. Okay, 25 people, I'm gonna start. Yeah, pretty much what Johannesburg said. Do whatever you can for the marks. Okay, anyways. Okay, in a red asterisk, I've showed things that are easy for the teacher to notice, that I've made easy for the teacher to notice for marking purposes. But essentially, for my rationale, I started with the aim of the experiment. So I just straight up said, um, the experiment aims to investigate how increasing the length of a current carrying wire in a magnetic field impacts the magnetic force induced on the wire. So pretty much for mine, I did, just for those clarifying, I did the force on a current carrying wire experiment. Does everyone know which one that is? Is it possible if I can access this exemplar? I mean, if it's recorded, it should be on the recording, so you guys should be able to access it there as well. Okay, so I just started with my aim of experiment, and then from here I went into my stating of the dependent variables, so kind of my lead up to the theoretical equation. So I just stated the variables relating to the theoretical equation. So I mentioned that current magnetic force on a current wire is related to magnetic field strength, current, length of the wire in the magnetic field, and angle the wire makes with the magnetic field. And I put an asterisk there because I mentioned I did the abbreviations for the B, I, and L to make it even more clear for the teacher. Just things like those. And I think the name of the formula, I did it as motor effect formula, but I'm not sure the actual name. Teachers had differences in what they wanted for the name between classes. So just make sure with your teacher you've got the right one. Essentially, we have the theoretical equation here. So I lead up the dependent variables to the theoretical equation. And once I've stated the theoretical equation, I don't go into the theory too much yet at the moment. This is kind of like my introduction. And then I go straight into the original experiment. So the original experiment paragraph is pretty important for the flow of your rationale. So some people, at least what I used to do in my assignments, I used to put the original experiment near the um, bottom of my rationale. But I ended up finding that, at least for this one, it made it much more clear if I had it above. So it's just about finding what flows better for you. So here I just talked about the original experiment, including the independent and dependent variables, which are highlighted in brackets. So I made that very clear for the teacher. I mentioned those variables, and then that's pretty much just one sentence. And then what I did is I said, okay, what relationship was found in the original experiment, and what why am I changing it? So what is the reason that I'm redirecting, refining, or extending? It's better, always best if you have actual reason why you're doing this. So I just said that it was because it had low reliability and high percentage uncertainties. High percentage on person uncertainties. The person who did this assignment faked the uncertainties. So because I don't think many of you would have remembered the original experiment's uncertainties or even did it. So I pretty much, not me, pretty much just faked this and said that there was no method to verify the validity of results why the original experiment is being changed. And then from here, after the original experiment, I went directly into the modifications to methodology section. So it's quite a big paragraph, but I pretty much followed one consistent structure throughout this paragraph. Um, the annotated exemplar, it will be on the YouTube video. It should be, but if you guys want after, I can maybe post the annotated exemplar. So if you guys want that, I can do that. Um, so after the original experiment, I pretty much go into the modifications to methodology, and the structure that I do is pretty much the same for all of them. I go original experiment. What did the original experiment have? Then I go into the new experiment, what I'm doing. So I'm redirecting, refining, extending, and then how the change makes an improvement. So does it affect, what does it affect? Validity, reliability? Does it allow me to do a different verification of validation of my data? So if I go through an example here, I say, therefore, the original experiment will be refined and redirected. So I just stated clearly, I'm not going to have extensions. I'm just going to have refinements and redirections. The teacher can see that. And then I just go into, since the original experiment only includes 2 trials, so this is relating to the original, the new experiment will be refined by including 5 trials. And then this is the reasoning: to reduce random error, increasing the reliability of data. So reducing random error increases the reliability of data and allows for the sufficient omission of outliers. So if I do have outliers in my data, I can remove them without it significantly affecting the data because I have 5 trials, which enables that. So that's just one of the examples, and I pretty much rinse and repeat that. So for the next one, I pretty much repeat: in the original experiment, there were no blah, 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 which meant this could not be evaluated. As such, this experiment will do this, allowing for the theoretical force. So it's pretty much just rinse and repeat, as I've said, throughout the modifications. Anyone have a question for this so far? Any questions? Doesn't look like any questions. Okay, I'm moving on. Okay, next section. Okay, so essentially later on in my rationale, I go into like more of a deep theory section. So this is pretty much just more deep theory. I'm talking about the right hand rule, um, magnetic force, what causes the magnetic force. So it's caused by blah blah blah, and I've just referenced it here. One thing I ended up including was a photo of the original experiment setup. This was actually our new experiment setup, but I just used it for my original experiment. Basically, um, one thing that I really want to make clear for everyone in the rationale is that you have to make sure that you get this correct, which is the Newton's third law of motion. So if you end up doing the force on the current carrying wire experiment, what happens is because the copper wire, as you can see in the photo, is fixed, because it's fixed here, what happens is if you're getting an increase in mass on the scale, that's because what the magnetic field is trying to push the copper wire up. But because the copper wire is fixed, it pushes down on the scale. So as you can see in the diagram on the left, the motion of the copper wire is actually going up. But because of Newton's law, because the copper wire is fixed, it's going down. So that's something that you might want to mention if you choose to do this experiment. So I said here, due to Newton's third law of motion, when the magnet exerts a force on the wire, an equal and opposite force is exerted upon the magnet. And then I've said the change that will be recorded on the scale. So following down the rationale bit, it's a pretty big section actually. I just go into F equals ma. So this is pretty much how we're going to calculate the force using the experimental data. Then I refer back to the theoretical formula, and I create a hypothesis now. So in my hypothesis, I use the existing theoretical formula that I had before, so over here, and I just subbed in the values. So we were going to set magnetic field at this. We were going to set current at this, length at this, and angle at this. And I pretty much just calculated the theoretical gradient. So this gave me a point of comparison in my graphing. So that's what I got. And I just evaluated it. So y-intercept, blah, 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 theoretical gradient, etc. And I just mentioned how the results can be validified. Research question. You want to make sure that the research question is extremely specific and clear. So one thing that you want to really make sure is that you're mentioning all variables. Like here for length, I even mentioned the specific lengths. And then I mentioned force measured in newtons. And I mentioned all the controlled variables in brackets. So magnetic field, current, and the angle with the magnetic field. So you really want to make sure being specific. But one issue that some people come into is you want to make sure that everything you've mentioned, though being specific, is relevant. You don't want to have irrelevant things in your research question that you don't mention on later on. Otherwise, it will actually mark you down. So you want to make sure everything's relevant. Question. What was the task sheet context question for the report? So you mean just the task sheet? What was the task sheet? Is that what you mean? Um, secret lover. The, um, oh no. Okay. The task sheet was pretty much just the experiments that who do you call it? Freakiest Darcy would have mentioned at the start of the of his section. They pretty much you have a series of student experiments. So I'm not sure what exactly your question is. I've chosen the I chose the force on the current carrying wire experiment, if that helps. Okay, I'm gonna move on. Okay. Okay, moving on to from the research question to risk management. So in the risk management section, our teacher also didn't want a table for some reason. A very interesting teacher. But what I did is I just had it as a short section. This should be pretty straightforward for everyone. There isn't really much I need to say. And then here, this is like what was said in the structure section. There were no ethical, environmental, or ethical risks. So that's pretty clear. Clear statement that I made here. Important. Raw data or faked. pretty much the person who did this faked all this data. Um, and so pretty much it was just kind of winged. So like you can see like some sort of variation and some sort of similarity. And then like the person who did this intentionally added in like a 0.56 here, so it's more reasonable. How do you fake data? Um, the person who faked data here, what they told me they did is they just got other exemplars that had data from other exemplars, and they pretty much just used that to help figure out what should be the trend. And then they also looked at other students in their class, other people who did the same experiment and tried to figure out. One thing you can also do is if you get some tutor um, for example, one of the mentors, if you get them to read over your experiment, they can help you fake the data. Um, Theoretically, I don't know if I'm allowed to say that, but because generally they know what is required. So rationale is in blatant language the way to go. Yes, you want to make sure it still flows. Like if you see mine, I just made sure really to signpost. So like I just said straight up the original experiment, and then I had in brackets independent variable, dependent variable. I mentioned the aim straight away at the start, and then I went straight into here, and I just like rinsed and repeated. You don't want to be having too much therefore, furthermore. You just want to make it just straight to the point. Yeah, get the theoretical data. That's a very good point, actually. You can also get the theoretical data to help. So you can see the gradient here. So if you're getting the wrong gradient, you can kind of estimate that. So here, this outlier is very important because it allows for a section to be, for you to add in a limitation and quite clear thing to talk about. So there's always a way to justify. And then raw data processing. Um, this is pretty much something also that some things tutors can help with if you get them to have a look. I got a tutor actually to have a look at mine here, and I noticed that I had mistakes. So it helps for us noticing things that you wouldn't otherwise notice as well. Same with the process data. Make sure you have all your units correctly. Pretty much straightforward things. One thing I do want to mention again, reiterate in the rationale, is the link between the original experiment and modifications should be very clear. So here I said high percentage uncertainties, and then I mentioned that it only had two trials. So there's a direct link between this and this. So why did it have this percentage uncertainties? Because it had two trials, and why I'm changing it. So make sure these paragraphs, your original and your new, have direct links. Justification for the redirection. You mean my one? Like my section gained full marks for that? Um, Someone just asked a question in the chat. Yes, my experiment to the chosen one was forced on the current carrying wire, and I changed the magnetic field strength. So if you see the photo here, if that helps, was my experiment here. And we added more magnets. So we added more and more magnets to change the magnetic field. Thank you, Fish, for that excellent guideline. Ethical assignment guideline. Okay. Bean, let me know if you come back on. I would love to answer your question. Moving on, pretty much my graphs here. Freakiest pretty much went through most of the things. Yes, you can copy the same experiment, but be really careful, of course. Um, Graphs, you can see here my teacher didn't want max and min trend line, which was pretty good for me. It was pretty straightforward. All I had to do was graph each of them. Oh no, they did want max min. Never mind. I didn't ignore that. They did want a max and min trend line, so I did end up doing a max and min. I think I didn't want to do a max and min trend line, and he forced me to. I know the other physics class didn't need to do a max and min trend line, so it does vary a lot. So I just did my max and min here. Freakiest pretty much explained most of that. And then here's just my experimental versus my theoretical. So you can see that one of the things that you want to notice when you're looking at graphs like this is I noticed that here they're pretty close, the gradients, and they kind of the data points kind of split up more and more as they get more out wide. So I pretty much asked ChatGPT and said, "Can you find a reason for why these data points get further near the end?" And it gave me a reason, and I had a thought about it, checked with other people, checked with the teacher, and it gave me a justification of something to talk about. I did an after graph, separate sample calc clarity, and then as you go on, you move on to the analysis and evaluation. The analysis evaluation is also, you want to be pretty clear. So this is again with the cutting words. I just said figure 3 illustrates a linear trend between this and this, straight up. And I said as length increases, and I just gave a data for the fact that it's increasing. So it increases from this to this. And then I gave data to show that it doubles, which illustrates the linear part of it. So two pieces of data, one for the increase and one for the fact that it's linear. Remember, all numbers and stuff don't work, so you want to add in numbers as much as possible, or equations, so these don't count to word count. Then I just went straight on to the mathematical relationship, stated it here, clear mathematical relationship. And then I went into explaining the R squared value and the low percentage uncertainties because they directly correlated. So having a high R squared value closest to 1 demonstrates that you have low percentage uncertainties because the gradient is a good fit for the data, and the data doesn't deviate from each other much. It stays in a linear relationship a lot. So I pretty much just combined those in the same section, as you can see in here. And then I went on to explaining the theoretical gradient and now comparing experimental versus theoretical. So here was just experimental, and here is experimental and theoretical. I pretty much just go through the gradient of this does not fall within the range of the maximum or minimum values of the gradient. So my max and min gradient didn't actually fall into the theoretical. Um, and I ended up having high percentage error of 12.74%. And then you always want to make sure you're mentioning validity and reliability. So this impact the validity of results. And then I mentioned that it has low absolute uncertainty, however. And then I mentioned the high percentage error, low absolute uncertainty of gradient, and high R squared value indicates that systematic error may have occurred in the experiment, reducing the validity of data. So I'm directly linking one of the limitations of my data to a type of error or an error. So here I've said systematic error. And then my next paragraph is pretty much just justifying the reasoning for what I observed before. And the way I did this was just by calculating the theoretical value of magnetic field, and I compared it to the experimental value of magnetic field that was measured. And I looked at how this would impact the data. And pretty much just because it's multiplication in the formula, F equals BIL, let me just write that here actually. Because it's F equals BIL sine theta, because you're timesing it, if you have um, a bigger value for magnetic field, the multiplication is much larger when you times it by the other variables. So it makes a big difference when you are because it's multiplication for larger magnetic field strengths. So it makes a bigger difference with larger magnetic field strength, which is in turn what caused my data to skew more as I went further out. So that was my reasoning. And then essentially, this is just one limitation. This is another limitation. And then I mentioned directly after an improvement, so it's clear. So I said this is a limitation. My teacher wanted improvement after, so improvement. I mentioned another limitation here, how this, and I had a photo, so it was related to the setup, how the setup kind of was less strong, or it could have introduced interferences in the magnetic field as there's more plates. Then I have one more limitation and an improvement for both of this limitation and this limitation. So I had a combined improvement. I had one more systematic error and another improvement. And then here I just chucked in some basic measurement uncertainties to be safe, just in case my teacher would cut me down. I decided to make space for it. So this is basic measurement uncertainties. Extensions, stating the reliability and validity for everything. Yes, that's again important. As Freakiest said, you want to make sure you're mentioning all of them. All of the limitations, reliability, validity for everything. You want to make sure that you're really focusing on that for your evaluation, especially. So my extensions, pretty much just brainstormed slash also got ChatGPT to help in brainstorming some good extensions. Um, Conclusion, once again, um, structure subject to teacher preference. Conclusion can vary a lot because technically, at least in our criteria, you didn't really need a conclusion for student experiment, but a lot of teachers wanted it. So in my conclusion, I just restated the research question. I then went on to state the experimental relationship and that the overall experiment was so overall statement on validity and reliability. And then I said the validity was limited. And then I just mentioned some of the biggest limitations as a summary. And yeah, this is my referencing, and that's pretty much it for
Oh,
the
I forgot to mention, use correct and up-to-date APA 7 referencing.
yes, that is very important as well. Um, I think you can correct me if I'm wrong, by the way, Freakiest, but for APA referencing, our teacher said you have to remove the retrieved from.
Uh,
So that was something that
I
we,
don't think it's that big of a deal. I had the retrieved on for things like Wikipedia, like things that were like constantly updated. But if you have like a an archive thing or like a research paper that like isn't gonna be changed, then you
yeah,
could just do like the link.
yeah. And oh yeah, in saying that, if you do have the wrong referencing, um, we used to have a communication section in ours. I know you guys don't anymore. The communication section worked such that if your referencing was marked down, you still got full marks for the communication section. So I'm not sure how your guys' changes now. And it also depends on teachers. Some teachers are really strict, some aren't.
Yeah, yeah. Again, check with your teacher. Like talk to them.
Um, mybib.com, yeah. So Johannesburg just gave one of the bibliography suggestions is using mybib. I use Word, but it's Word kind of stitches you up in terms of how up to date it is. But
Hmm. Um, is that the exemplar section done? Does anyone want Polaris to go back through any of the exemplar, any sections that you want to see redone?
does anyone want me to explain anything or checks a certain section? Oh, someone actually pinged me earlier and I missed it.
I think at this point, I think it's safe to say that we can like start the
Yeah.
Q&A.
Sure.
Okay, I can't screen
Oh
share
yeah, let
because you're.
me. You go. Just
Yeah. Yeah. So that's it for the PowerPoint and Exemplar. We are now gonna do a Q&A for anyone that has any questions whatsoever. Okay, I'm just gonna ping everyone. What ATAR did I get? I got a 99.85, the same as Ella and Jonah's.
me, I got a 99.7, so not as advanced.
Yeah, but we both got full IAs, right? From eStarflight. How hard would you say it is to get full marks on IA2 and then IA3 science? Um, Full marks on IA2 is, it really depends like how confident you are with writing a student experiment. It's definitely like really doable, and like it's much more, what's the word? It's much more like reassured that you could get a 20 out of 20 since it is an assignment and not like a data test or an exam. And same goes for the IA3. My best advice is, if you're in year 11, try um, to really perfect your IA2 and IA3 writing style in in year 11, and then that will train your year 12 self to be able to replicate and sort of refine what you did in year 11 to year 12 standards and get as high of a mark as possible. Uh, Casey said, "I heard that physics IA3 is cooked since it's Unit 4." Yeah, it is. It is very cooked, but it depends what you do for your research investigation, like what your question is. Me, I did one-way speed of light, which was genuinely like horrible to do. So if you are doing anything to do with the speed of light or relativity, brace yourselves for a really bumpy ride. But the good thing is that your teacher should be like very understanding, and like the wouldn't have as much of an expectation to have found something concrete, because even like with the one way speed of light thing, even like the top researchers in the world have done like countless tests and like research, and they haven't even come up with anything concrete. So it's not like you're gonna come up with anything concrete. So the uh, if you're doing a really cooked thing, check with your teacher what it is that you need to do to essentially fulfill the research investigation. What do we study in uni? I'm doing a Bachelor of Music at the University of Melbourne. Polaris is it dental?
Yeah,
Uh,
dentistry. But you did get that incredible scholarship, so
yeah, yeah, yeah.
it's worth mentioning.
I have a Chancellor scholarship to the University of Melbourne. Yeah, but it's only for music though. So yeah, I kind of missed the ATAR for the general one. A question from A. What physics student experiment would you recommend for the IA2? Most recommended to least. I The one I did was the inclined plane, and I extended it with like I made it more complex by doing rolling stuff. Personally, I would probably rank that as second best. It's very easy to do, and it's like you can add complexity, um, and it isn't that hard to like add complexity, and the experiment's like really quick and easy to get done. I think probably I would recommend the one Polaris did, like an electromagnetism one, since there's a lot of stuff to talk about and it shows one of the harder parts of Unit 3 theory very well. I think third, like third in the list is probably projectile motion, and fourth is circular motion. Those things are just way too hard to get like consistent and like really hard to set up and record, and circular motion more so than projectile motion.
Yeah, there is lots of exemplars for projectile motion. But there is a few on FBIL as well. You can pretty much should be able to get full marks in everything, like you said.
Yeah.
Inclined plane is also not bad, but theory, you might well struggle a bit in terms of theory for that in the rationale.
Mm. Yeah, yeah, that was one thing that I found was lacking, and I had to go get out of syllabus content to do with like moment of inertia because we were rolling balls down the inclined plane. So if you are doing something lacking in theory like titration or inclined planes, you might have to make it more complex by adding out of syllabus stuff. Again, check with your teacher for how to do that correctly and if it is allowed. A question from Ditto. What would the hardest subject be and what's the easiest? In my opinion, for QCAA, it genuinely depends. Like, if you're good at math and science, like, even though a specialist in physics might be like technically the hardest, uh, if you're like really interested in them and like you like learning them, then whatever you like and you're motivated in studying, you'll be like you will find it rewarding to study, and it won't be as hard as it is. And if you are like sort of dreading a subject and like aren't really motivated in it, that will make it seem that much harder than it what it actually like kind of is. Like for me that was literature. Like the creative stuff was cool, but when it came to the external and like actually analyzing it, especially in like an unseen exam, that was like really cooking me. And so like I personally found that like harder than specialist, which is like it's entirely subjective.
Yeah, I'd agree. It's pretty subjective, and I think most people should be capable for any of them, as long as they're putting in the work.
Yeah, definitely. From Casey, no, no, the if I applied for the scholarship, no, Melbourne Chancellor Scholarship is you don't have to apply. You just get an email from them if you're eligible and um you've applied to the University of Melbourne as one of your VTech preferences. And it doesn't even have to be the first one.
Pretty straight, crazy scholarship. I
Yeah,
can't lie.
yeah. There were more questions.
But even though you're doing Bachelor of Music, you get a any choice of post-grad degree, right?
Yeah, but it depends on the postgrad. Like with some of the science ones, they say you have to do a cognate bachelor, but like with stuff like Doctor of Medicine, like you just have to pass the MMI, like the mini interviews, which is genuinely crazy.
Oh yeah. Oh, I
Uh,
see.
yeah. A question from Casey. The sorry. Just kind of got away. What QCAA subjects did I take? I took specialist methods, physics, chemistry, literature, and philosophy. The results I got for my subjects were 99 specialist, 100 in methods, 100 in physics, 99 in chemistry, 98 in philosophy, and 98 in literature. From the chosen one, do I reckon teachers are more flexible? Yeah, yeah, 100%. They are definitely more flexible during year 12. Like, assuming you have like really good teachers, even like the ones that like aren't as super like dedicated towards their students, they still will be flexible because they all want the same thing, and it's to have everyone get the best marks as they can.
Spec IA2 masterclass on the examination. Yeah. When do you guys have your Spec IA2 masterclass? I mean, when do you guys have your Spec IA2?
Ooh, okay, week 9.
Week
On
8, term 1.
Friday. Oh, good luck. Good luck, eh?
1. Yeah, sure. I'm sure the mentors can organize. We can organize a Spec masterclass. That's pretty easy.
Yeah, yeah.
Pretty
Uh,
organized.
so someone asked if I can do a philosophy IA2. Uh, yeah, that is the one about Stoicism. Am I correct? Yeah, I can definitely do one. It's just if there's enough demand for it, because I know philosophy is a fairly niche subject, especially compared to like specialists in physics and stuff. Hmm. Oh yeah. While you guys are all here, um, what what upcoming masterclasses do you want? Like, does anyone have any like really spec spec IA2? Okay. How to beat scaling? IA3 sciences. Ooh, okay, yeah. That would be like in like at least a term's time or so, wouldn't it? Unless like some of you start it right after your IA2. Yeah, yeah. I agree with Casey. It seems a bit too early. Yeah, I can definitely look at doing an IA3 sciences one.
I'd be happy to join into whatever mentors want to do a chem masterclass because
Yeah.
I enjoy that more than
Oh, also, I was also thinking of doing a physics electromag masterclass. Uh, does is anyone interested in that? And what time would people like it to be? Same time as right now? Like right now, right now? A week from now. Oh god. When this one's like Saturday 7 p.m. Or I guess flattest it would be 8 p.m. for you and me. Yes please. The electromag, physics and chem electrochem. Unit 3 topic 2. Yeah, I'll definitely I'm definitely happy to do electromag and physics. I think someone else is doing chem though. Correct me if I'm wrong. Flatus, your HSC. Tifu, we're doing a Q&A, so if you have like it's like still part of the masterclass, it's just like the ending bit. If you have like any questions you want to ask us, just ask away. like especially related to the student experiment. No, 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 Flatus. We don't discriminate against HSC, but like it's it's like why you going to kindergarten to learn how to do an external, like that sort of thing. Yeah, I mean I guess I could do I guess I could like talk about some HSC topics which like motors, right? Is that we don't do motors. We don't do I don't think we do particle accelerators. The with the electromag, the highest thing we like the hardest thing we do is like induction, and that's it. Like we don't even do applications of it. Um, from Ditto, are these books great? The Oxford Study Buddies, I don't know. I've never used them. I think like ask some of the other mentors. Like I think Swarnham might have used one. Like I think some might have used one. The Chosen One. What made me choose Bachelor of Music? I was already interested in doing Bachelor of Music as like a dual degree with like maths, um, and like getting the scholarship for this, um, was like the final deal. Like I'll do so like I'll do it with a scholarship, and then like I'll do a diploma of maths with it. So it's kind of basically the same as doing a dual degree. Someone was asking about the Oxford Study Buddy. Oh yeah, yeah, Flatus. Yeah, I kind of agree. Like like I've seen stuff in like HSC about like, or maybe it was VC. Like it definitely in VC. There's like in chemistry there was like stuff like chemical uses of chemistry of like um herbs used by like Aboriginal people. Yeah, yeah, yeah. I mean, is it like good content, like hard questions, or is it just like projectile motion? Oh damn. Yeah, yeah. I mean that to be fair, that's kind of like every science, like especially chem. You just have like random definition stuff popping up all the time. Or do I reckon philo was my fifth or lit? I got the same mark in both of them. I genuinely think it just depends on the scaling. Like it could have been either one. Yeah, Jesse, yeah. Uh from KC, isn't uni starting soon? Yeah, uni starting soon for like for people in UQ. I know it starts like next week. For me, it starts the week after. Like my O week's next week. Um, from Avni. How often did you guys study per day? I was low key kind of chill during the first half of year 12. Like, I was just like mostly locking in for the IAs, especially the science ones, because you have to like put in like a decent amount of effort and like write quite a bit. But once the term break from like term three holiday started, I started like locking in and like redoing my notes and like doing practice questions. And around the start of term four, I was like doing like at least 3 hours per day. And then once it got to like external exam block and like we didn't have to go to school anymore, I was like probably doing like whole day study if I could. Oh, spec PSMT masterclass. Ooh, I'm not sure. Does if everyone wants one, but the thing is, the PSMT is like generally so different. Like it's it's hard to do one for all of them. Casey, do I recommend doing practice questions at the start of year 12? I honestly, I would recommend doing a couple a day. Like not cramming like a bunch at the start because you'll just forget it mid-year. But like just like a couple a day. Like even just lurk on QSH and like just look at what people are posting in the help channels and then like try and solve them yourself. Like it's a great way to like be productive when you're like sort of procrastinating. Like being productive while you're on your phone, you know what I mean? The chosen one says, excluding everything, what's my average amount of studying in hours every day, including weekdays and weekends? During externals, I probably a good 6 hours per day. Like I was doing at least like two formatives, sometimes even doing like three or four a day. And the formatives were probably like 1.5 to 2 hours. So I probably six is probably a good estimate. But before the external exam block, it was like, it was really chill. Like
Yeah, I'd agree.
you don't have to be cramming in like the start of year 12. Like just lock in for your IAs, and keep a regular pace, and you'll be fine.
As long as you're keeping on top of your IA
Yeah,
assignments and
definitely,
stuff,
definitely.
like you're not delaying them. So if you get to them early, they don't, they give you like, they gave us like 8 weeks or something for our student experiment, which is like crazy. So you should have it, you could easily get that done in like 2 weeks if you really locked in. So then a lot of the time you have free time for other, other assignments or whatever you need to focus on. As long as you're not leaving anything behind, you'll notice it's actually quite a lot of more time than you think. There'll always be busy periods where it's like you're
Yeah,
studying more.
yeah.
That's why it's kind of hard to quantify like exactly how long you were studying. But for me, it could range anywhere from coming home straight away and studying, to like coming home and literally not studying that entire day, which is
Yep,
kind of bad because obviously, you being consistent is always the best. So
yep.
yeah, as long as you're consistent and you're not forgetting knowledge and you're being on top of your learning, then that's the most important thing.
But also like remember to like take breaks, especially like like especially if it's not externals like mid year. Like just you can chill some days. Like don't be too hard on yourself. Question from KC saying, how did you all study? Personally, the best study I did was rewriting all of my science notes from my paper notebook to my laptop because that helped them make them more tidy, and the rewriting of them helped me memorize them way more than doing any practice questions would. And then once I did that, I was doing like practice questions a ton and like practice exams, and whatever I got wrong, I would write down in like an Excel spreadsheet where I kept um all the other like info, like the mark I got in the exam, the time I took. Like I would just keep a um detailed logbook of the mistakes I made, so I would remember not to make them again. Casey said, "Do I recommend speedrunning the IA as fast as you can so you can study for external?" By speedrunning, do you mean getting it out of the way as soon as you can, or like rushing it? Because if you're talking about rushing it, then definitely no. Like your IA still counts towards your total results, and it's good to like get it out of the way first so you can focus on like other stuff and like do like practice questions or something. But if you're trying to get the IA over and done with so you can study for external, I don't think it's that worth it, especially since you won't know half the content on the external if by the time you're doing most of your IAs, except like maybe IA3.
Yeah, I mean, I agree with that. Like, you find that you'll have a lot more. time to revise than you think in between the period when you finish your IAs and then you have your externals. So pretty much the entire Unit 4 and a lot of Unit 3 I like relearnt in that entire gap for chem and physics. Between the IA finishing and the externals, which obviously you not the best thing, but then I still, did reasonable in my externals for them. So
Mm.
it's not like you have to start learning everything now.
Yep.
It's like focusing on the present kind of, if I was to say, and solidifying the present kind of thing.
Yep. You have like genuinely you have a full year to learn for each subject. What I would say like 1 week to 2 weeks like worth in total of content. You have a full year to learn that for each subject. So you definitely have time. People are asking about my Excel, so I'll just see if I can pull it up. And then okay. Yeah, I'll take a screenshot of it. It's a bit hard to see, but uh like I'm recording with OBS right now, and I can't really like search through my files to pull it up, because like that would be kind of like doxing me. Uh, so essentially, what's the in that screenshot is like a column for each subject, and like each column was like sort of there was like separate columns for each subject. There was a main one for the QCAA, another one for company papers, and another one for like interstate papers if I did any of those. And what I would have is the name of the paper, the mark I got out of, then I got then I put the rating, like the score, like the 95% or like 92%. Then I put notes on the about the exam, like what I got wrong. Then I yeah, that's it. From KC, everything is done by the syllabus dot points and what it covers. Yeah, essentially I just went through the syllabus and I like sort of separated like sorted it out using the syllabus. Like I would primarily base it off of my paper notebook and just write whatever I had on from there onto my website and like make adjustments if I needed to. But I would also check the syllabus to see that I wasn't missing out on anything. Like if I was away for class, one time, then obviously it wouldn't show in the notebook, but it would show on the syllabus. Okay, see, this was done all during the break for external. No, I'd say about like a third of it was done uh from the break, starting from the break before external to the lead up to the actual start of externals, and then from then on I was like I had all the time at home and I was doing that at home, so like I had more time at home, so it started filling up way faster. So probably like 2/3 of it was done during the external exam block. Yeah, Casey. Like I said, you have a lot of time. So if you don't know Unit 4 content right now, don't stress. Like you will like you will definitely have enough time to do it after you've learned Unit 4 content. Right now, you should be focusing on like just keeping on top of your sorry, if you want to do like practice questions and practice papers, just do ones specific to Unit 3 and just keep on top of your knowledge for Unit 3 and then do that for when you learn Unit 4. A for how accurate the ATAR calculator is. If you're like aiming for like a 99 point like plus ATAR, I don't think I would trust it because it is very misleading with the scaling at the highest end. Like definitely, sorry, like if you're aiming for 99 plus in that ballpark, I would say it's a good estimate for how well you're going. But if you're seeing like the finer details are like 99.8, 99.9, you are not gonna, it's not gonna be accurate, especially because it doesn't factor in subject scaling as like well as it needs to. Yeah, it gaslights 99.95 so much. Kevin 26. I use flashcards for the theory in physics and chemistry just because there was like a lot of like random info or like specific pieces of info that you had to mention in each question. So I use flashcards to memorize like each of the things you needed to mention in each question. And also I used flashcards to memorize reaction pathways for chem. Yeah, I used Enki.
That kind of flashcard kind of comes down to the person as well.
Yeah, yeah.
Um, like some people just work better, like their memory works really well by writing down and answering the questions. I just found watching videos and doing active like questions to help me more. So
Yeah.
it really depends on the person and what you find works for you. Because a lot of the time I found myself spending more time writing the flashcard than actually revising. So if you're not
Yeah.
someone that will fall into that trap, then flashcards can be good.
At the same time, writing info about the question does help, like with your understanding of it.
True.
Any more tips for year 12? I think I've probably went through all that I can. Um,
If you
yeah.
do want uh more tips, you can check out the YouTube video on the mechanics of QCA on Ollie BD's YouTube channel, so the QSH channel as well. That goes through pretty much subject selection and tips and everything.
And one thing I would say for year 12 is like this isn't like academically related, but like just make the most out of it. Like I know you hear that a lot, but like genuine, like it's the last time you're gonna be at school with like people you've known for almost your whole life. So just like make the most out of it. Like go to as many events as you can. Like provided like you aren't sacrificing your study too much, but like go to like school events. Go to like hang out with your friends a lot, and you'll find that like you'll have done like so much during year 12 that like you would have done like 3 times as much stuff in year 12 than you would have in year 11. Like that's definitely how I felt. It like genuinely year 12, it like makes you so productive, and like that is like make the most out of it while you can. Ditto. You have to go. I'll see you then. A fish. That's not nice. You're welcome, fish. Ella, give study tips right now. Can we get a Science IA2 masterclass? I don't know. I don't know. Like it's kind of a niche
Wait,
thing.
what?
Like
What does that even mean?
if enough people want it, I guess. But like I like personally, I've never done a Science IA2, so like I have
Wait,
no idea.
what? What
I
is
have
this?
no idea where to start with those.
Wait, was this another Science IA2?
No, no, Jeef is asking for a Science IA2 masterclass.
Wait, was this not a Science IA2 masterclass?
Oh, oh yeah. Oh, Jeef, you silly baka. IA4, yeah. Oh, sorry. This is Oh shit, I must have confused my numbers.
That's right.
Lloyd, you want to repeat the whole 2 hour class? You can watch it on YouTube. Like, probably,
Oh my
eventually.
God, bro. But I was like
Speaking,
falling asleep or
yeah.
something and got confused.
Speaking of YouTube, I think we should end the recording here. We'll still be in VC if anyone wants to ask questions, but I think it's like we're kind of dragging it, so
Yeah, that's true.
I will end the recording here. If you followed us all this way from YouTube, thank you, whoever you are. I really hope this has helped you, YouTube person. And yeah, so that is the masterclass done.